Thank you. I will start with you today just to have some exercise and to solve it together. I prepare for you some. Do you see my screen?
No.
Now?
Yes, doctor.
Okay, good. I choose some of the exercise randomly, but depends on different ideas. So let's go for this one. Find the partial derivative, partial f by partial x, partial f by partial y, for the function of two variable x and y, root square of x squared plus y squared. As I said, when you have two variables, they call it two independent variable x and y. So it means you have a first derivative with respect to the first variable x and also first derivative with respect to the variable y. This is why how to distinguish between d by dx and partial x. Okay. Now, very similar to the ordinary differentiation, your solution depends on one variable function differentiation, right? So first of all, I can handle my function better than having the square root of x squared plus y squared. I can write it as, instead of root square, I can write it as what? Yes, I hear you.
Power of half.
Power of half, excellent. This is easy to handle with this one. Now, partial f by partial x. Also, I can write it using this notation, fx. Okay. How to differentiate? I'm differentiating with respect to x. I differentiate normally, right? So when you differentiate any power, you just get the power down. Okay. And then write your practice as it is and subtract 1 from this one. Okay. Then get inside. As I told you all the time, the derivative is like a box inside the box inside the box until you finish with the last piece. So the first box, I differentiate the first box, which is a practice. Bracket. The bracket, going down the power, subtract 1. And then I go inside the bracket. What inside the bracket? X squared plus y squared. So I'm differentiating partial by partial x for x squared plus y squared. This is exactly like the implicit derivative, if you remember, right? Now I have half. This one will be x squared plus y squared to the power what? When I subtracting half from the minus 1 from the half, I will end up with minus half. Okay. I'm differentiating partially with respect to x. So y for me is a constant, right? So I'm just differentiating x squared to x plus the derivative of y squared is 0 because I consider y as a constant with respect to x. Fine. Now this minus half, I can get it down as 2 here, x squared plus y squared to the power positive half, because I know x to the power m is equal to 1, x to the minus m is 1 over x to the power m. Okay, now I have 2x, so I can write 2x here to make it easy. If I would like to write it in I cancel out this one with this one. So I end up with what? I just choose a nice color for you. So I have x over root square of x squared plus y squared. Is it okay?
Yes. Yes.
Do you mind to take a screenshot and put in the chat, please? What I'm going to do now, I'm just deleting x and replace it by y, right? Okay, so let's go for deleting this one. Thank you. I'm just deleting everything here. Sorry. So I delete this one and I make it what? I make it partial y. partial y. So this one will be what? With respect to what? Y. So this is fy. Also, I do the same, but in this case, I change x by y. Right, okay. So which one will be 0 in this case?
X
This
y.
one will be 0. Yes, this one will be 0. Okay, because x is a constant with respect to y, and here 2y. So this one will be differentiated. This one will be 2y. Also cancel this one. So what's the difference? It's just when I consider x as a constant, when I differentiate with respect to y. Okay, so the derivative of any constant with respect to any variable will be 0, right? Easy?
Yes, easy.
Okay, take a screenshot, please, and put in the chat. Let's go for the next one. If you have any question before we go to the next one, please ask.
No, doctor.
Okay. Now let's go for this one. I would like to have partial f by partial x. So what I'm going to do, I'm just having partial f by partial x, or you can write it easily for you. So partial by partial x for len, I remember, I forget this one, is len x plus y as far as I remember.
Yes.
Question number 15. Yes, len x plus y. As I said, the big box is the len, the inside box is x plus y. Okay, so normally I differentiate the len. I know the derivative of the len is 1 over whatever inside the len. And then I'm differentiating with respect to x what inside. Okay, now it's 1 over x plus y. What is it differentiating with respect to what? X. So y is constant. So the derivative of x with respect to x is 1. The derivative of y with respect to x is 0. So I end up with 1 over x plus y. Is it okay? Now let's go for the first derivative with respect to y. So partial f by partial y, which is fy equal to partial by partial y for my function. Again, the derivative of len is 1, whatever inside the len, and then I differentiate what inside the len with respect to my variable. Okay. Now, what is the derivative of x with respect to y? Is 0. The derivative of y with respect to y is 1. So I end up with 1 over x plus y. Is it okay? It's very important notes here. The derivative with respect to x and the derivative with respect to y, I have the same answer, right? Which mean
Yes.
the component of the slope in the x direction and y direction are the same, right? Because I know the first derivative represent what? The slope in one dimension. Represent the components of the slope in the two direction. Okay? Easy? Take a screenshot, please, for this one. Now let's go for the next one. I have a function cosine square 3x minus 2 minus y square, I think. This is minus y square. Can check number 18, please. Yes, 18 minus y square, yes. Minus, I miss. Oops. Minus y square. Again, I'm looking for the first derivative. Partial f by partial x for cosine square 3x minus y square. This is exactly like what? Like partial by partial x for cosine 3x minus y square, all of this 1 to the power 2. So my big box is the square, okay? This one. So I'm just differentiating the power. How to differentiate the power? Yes, I get the power down, and I have cosine 3x minus y square to the power 2 minus 1. Okay, just make it very tight here. So I get the 2 down, and I have cosine 3x minus y square, and this one, the power will subtract it by 1. And then I go inside partial by partial x for what inside is cosine 3x minus y square. Okay. Now I have minus 2 cosine 3x minus y square, and the power 2 minus 1 is 1. That's enough. How to differentiate this one? This is a smaller one. What is the derivative of cosine? Is minus
sine.
Sine, the same angle, 3x minus y square. And then I go inside. So I partial by partial x for what inside, which is 3x minus y square, right? This is how to deal with. So the big box is a square. The smaller one is cosine. The smaller one is the angle. The smallest one is the angle. Now I have minus minus will be what? Plus cosine 3x minus y square sine 3x minus y square the derivative of 3x minus y square with respect to x, so y is constant, so I'm just differentiating the 3x. What is the derivative of 3x with respect to x? Is 3. Okay, if you would like to write minus 0 to make sure this is a 0 for this one. Now I finish 3 times this one. It is better to write the number as a coefficient first. Cosine 3x minus y square sine 3x minus y square. Just this is my what? My fx. This is my first derivative with respect to x. Do you have any question before we differentiate with respect to y?
No, doctor.
So take a screenshot for this one, and let's replace every x by y and see what's going on.
Done, doctor.
Okay, so now if I'm going to go for differentiating with respect to y, so this one will be replaced by y, right? This one will replaced by y, right? This one will replaced by y. This one will replaced by y. So now what's going on? I'm just making it in a nice way. just do not to be ugly. Okay. Partial y, partial y, partial y, okay, partial y. Now what's the difference in the last piece is a difference, okay? Only the angle is different. So what is the derivative with respect to y? X, the derivative of x with respect to y is 0 minus
0.
the derivative minus 2y, right?
Yes.
Yes.
Now I just multiply this minus 2 by here, so it will be minus 6y cosine 3x. Sorry, I missed to change this one.
Doctor, 3 must not be included.
Sorry?
3 cosine 3x y. 3, it's the derivative for x.
It's 0.
It must remove it.
Yeah, I remove it. It's 0.
No. دكتور السطر قبل الأخير موجودة.
I differentiate now. This is the power, okay? And the derivative of cosine is minus sine, the same angle. Then differentiate the angle with respect to y, right?
Yes.
So the derivative of 3x is 0. The derivative of minus y squared is minus 2y.
Yes.
So this is minus 2y times 3 is minus 6.
Yes, this 3 is
Why?
the derivative for x when we differentiate.
Ah, yes, I got you. Sorry about that. Yes, I got you. I'm sorry. So minus 2y, 3x minus y squared, sine 3x minus y squared. That's it. Easy?
Yes.
Take a screenshot, please. Now let's go for the second derivative, second partial derivative, okay? So if you would like to have the second partial derivative, you should have the first derivative first, right? Okay. So how many second derivative I have? If I have two variable, I have fx, x, and I have fyy, and I have fxy. But before to find this one, I have to find fx first. Okay. I have to have fx fx, and here I have to have fy and then differentiate it. Here I can start with fx or fy and differentiate it again. Okay, this is the second part order partial derivative. So now to solve this one, you cannot find the second derivative unless you have the first derivative. Let's go for fx. How to differentiate this one? This is a partial by partial x for my tan inverse of y over x, right? So first I'm going to have the big box is the tan inverse. The smaller box is y over x. So I differentiate. What is the derivative of tan inverse? 1 over 1 plus the angle squared. And then I go inside, differentiate my angle. Sorry, it is not angle. This is the value of the tan. Sorry about that. Okay. Now I have 1 over 1 plus y squared y over x squared. And what is the derivative of x with respect to? It is better to deal with this one as x inverse y, because I have 1 over x is exactly x to the minus 1, right? So it is easy to deal with this one, right? Now I'm going to differentiate with respect to x. So 1 over 1 plus y over x squared. Okay. And then what is the derivative of x to the minus 1? It is minus x to the minus 2, right?
Yes.
And y is like 5 or 3, so you can take it outside, right? So you can take this one outside because it's multiplied, it's not added. So you can take it outside, okay?
Yes.
Because when you partial by partial x for 5x minus 1, you just take the 5 outside. Why I consider y as a constant, so I can take it out because I differentiate with respect to x. So minus x to the minus 2, and I get this one out. X to the minus 2, I can write it 1 over x squared, right? And don't miss this minus. So I will have minus y over 1 plus, I can expand this one, and here I multiply by x squared. When you multiply x squared inside this 2, what do you have? I have x squared plus y squared, because this one will be cancelled with this one when I multiply inside, right?
Yes.
Shall I say again?
Yes, doctor, please, Yani.
Okay, now from here, y over x, it is better to have what? It is better to have x up, right? So y over x is exactly x to the minus 1, 1. Because I know 1 over x is x to the minus 1, right? Then, how to differentiate partial by partial x for x inverse y? Once I differentiate with respect to x, so y is constant, so I can take it outside. Okay? Now, y, what is the derivative of x minus 1? I get the power down and subtract 1, so I will be end up with this one, right? Now, it is easy to have x to the minus 2 is 1 over x squared. This is what I have done down here, okay? So once I get the x squared down, I just y over x squared is y over x all squared, right? X squared times y squared over x squared will be y squared. X squared, I'm sorry, x squared times y squared over x squared is y squared, right? Easy. Now I get the first derivative. How I can get the second derivative? Okay. Take a screenshot, please, because I'm going to go for the next page. Shall I repeat again?
No, doctor, I got it. Thank you.
Okay, good. Once I have fx fx, just before I forget, I'm going to write it here again, equal to minus, as I remember here, minus y over x squared plus y squared, right? Minus y over x squared plus y squared. Now I am going to get fxx. fxx is a partial by partial x for fx. Okay, so I'm going to go for partial by partial x for what? For fx. What's fx? Minus y over x squared plus y squared. It is easy to take this one up because 1 over x is x to the minus 1. So I'm going to write this one as partial by partial x for y minus y x squared plus y squared to the minus 1. As I said before, I'm differentiating with respect to x, so y is constant. If it is multiplied, I can take it outside, right? So I'm going to take this one outside. So I will have minus y outside, partial by partial x, for x squared plus y squared to the minus 1. Okay? Now let's start to differentiate with respect to x. So minus y. How to differentiate the bracket to the power? I get the power down and then subtracting 1 from the power, and then don't forget to differentiate what inside this one, x squared plus y squared. Okay? Now, it is minus minus will be positive, y, x squared plus y squared to the minus 2. What is the derivative of x squared plus y squared with respect to x? It is 2x for x squared, and it is 0 for y squared because I'm differentiating with respect to x. Now, I can get this one down to make it 2xy over x squared plus y squared. I make the power positive if I take it in the denominator. So this is my fxx. Okay. Is it clear?
Yes.
Okay. Take a screenshot, please. Now I'm going to differentiate fx with respect to y, right?
Yes.
So what I'm going to do, I know fx is minus y over x squared plus y squared, right? Now to find fyx, which is exactly partial by partial y for fx, right? So I'm going to go for partial by partial y. For my fx, I'm just have it here. Minus y over x squared plus y squared. Again, it is better to have x squared plus y squared up to make it to the minus 1, right? So it will be minus, I'm differentiating with respect to y, so I keep this one minus y. Instead of having division rule, I will make it to the power rule. So I take this one to the minus 1. Now I have a multiplication rule because this is a function of y and this is a function of y. I cannot take y outside as I have done when I was differentiating with respect to x. Okay? Because y is constant here with respect to x, but y I cannot consider it as constant, right? Now I have a multiplication rule. What is the multiplication rule says? Just take the first one and differentiate the second one, plus take the second one and differentiate the first one. Oh, sorry, I make a mistake and you didn't notice. I'm differentiating with respect to y. Now, what is the derivative of this one with respect to y? X is 0 plus 2y plus, this is a multiplication rule again. This is the second one. What is the derivative of minus y with respect to y? It is minus 1, right?
Yes.
So I'm just multiplying this one inside, so I have minus 4y plus, I missed the minus 1 here. It is better to have this one down, so I can write it as minus 1 over x squared plus y squared. Is it clear? So if fyx, by the way, is the same as fxy. Which is the same as fxy. Okay?
Doctor, the differentiate for x squared plus y squared, it's to the power minus 1.
To the power minus 1? Yes, we missed the minus 1 here, right?
Yes.
Thank you. Catch it. Very good. So we have a mistake here. So the first part is wrong, right? Okay, so I have fyx equal to minus y. Yes, we missed this one. How to differentiate this one? You have it x squared plus y squared to the minus 2 and partial by partial x for x squared plus y squared.
Also minus 1 from the beginning.
Sorry? Yeah. Y squared. So this is okay. Minus y, partial by partial x, partial y by the second one. The first, okay. Now is it okay?
We missed minus 1 from the beginning.
Yeah, so it will be minus 1 here. So this one will be positive 1, right?
Yes.
Okay, so this one, thank you very much. So you have minus y and you have minus 1, just to be very clear, right? So I have y x squared plus y squared to the minus 2. And what is the derivative of this one with respect to y? We differentiate with respect to y. So we have 2y, 2y plus x squared plus y squared to the minus 1. And I have minus here, so I'll just make it minus 1. Okay, it will be minus 1. And here it will be minus. It is better to write this one down here. So it will be 2y squared over x squared plus y squared to the power 2 minus 1 over x squared plus y squared. Is it okay?
Yes.
This is fyx. It is the same as fxy because we know the second derivative are the same if you start with x or start with y. Okay, so without fx I cannot find fxy, so I start with here. Okay, and then we differentiate with respect to y. Okay, now I finish my duty. I'm just waiting for the Matlab, how to differentiate this one using Matlab. Okay, did you take a screenshot for the last piece?
Yes.
Okay, anyone can share the Matlab or I can share it with you. Okay. How we can write the derivative here I'll just back here. How we can write this one down? Can you let me know? First, I have to define my variable. What's my variable?
X and Y.
By using the command sims, right? So sims x space y, semicolon. You can write your function y, right? Or you can write, you define x only. Sorry, x and y, sorry, and y. And then you can define your function f as what? Tan inverse. How to write tan inverse by the Matlab?
A tan.
A tan, excellent. A tan, what is the angle inside? Y over x, right? Can you try with me, please, in your Matlab mobile app? I finish, define f. I would like to differentiate this one with respect to x. So what is the derivative command? Def? Yes, I differentiate f with respect to x. So I'm just comma x. Okay, and then I press enter. Yes, I have. Can we make pretty just to read it at the math mode? Pretty, my answer here. I prefer to call it fx, right? It is the same answer as ours here. Minus y over x squared plus y squared. Yes, it is minus y over, yes, this is before we multiply. Okay, so the same answer, right? Okay.
Yes.
Now let's go for the fy. I'm just copying this one and change x by y, right? And I like to call my result as it is, because this I call it fy, so I call it fy, right? Because I know this is the derivative of f with respect to, and change x with this with what? With y. Now I have the same. I use a pretty answer. No, it is not a pretty answer because my answer now, it has a name, fy. So I change this one by what I have as answer, fy. Yes, it is the same as our solution here. Okay, what's our fy? This is our fy, yes. We didn't find fy, right?
No.
We didn't find. Okay, if I would like to have fxy, what I have to do? Is it Matlab? I have too many things here. Wow. Okay. So how I can write the second derivative? Again, you have to define your variable by the command sims and space between the variable. You define your function as a tan, because this is how to write tan inverse. What is the function? Y over x. Okay, now I define my f. If I would like to have fyy, so, or fxx, how I can write the differentiation for the, yes, I know, def, open bracket for my function as I define, comma, and write x and write 2 to give me the second derivative, right?
Yes.
Now I have the answer. I would like to use the pretty command to have it in the same handwriting. Okay, it has a name called fxx. Don't write pretty answer all the time if you give a name for your result. Okay, this is the same as our fxx. Okay, if you have the common factor and factorize this one. Okay?
Okay.
Easy? So you
Yes.
can handle with the Matlab, you can handle with the... If I would like to have the derivative with respect to x and then y, what I have to do? Shall I write it def fxy? Shall I write def x and then y? If I write like this one, shall I have something? Is it the right answer? Oh. Hello? No, this is completely wrong, right? This is not our answer, right? So the right answer to do this one is what? Can you tell me, please? As I understand mathematically, I have to differentiate fx if I'm looking for fxy. So first, I def with respect to x, okay? And then differentiate again, def, the result of this command. Catch it? With respect to what? Y. Okay?
Okay.
So this is what you used to do with the, as we said in our mathematical one. Yes, fyx is a derivative with respect to y for fx. So I'm writing the command for fx, and then I have a command for the derivative with respect to y. So you have to understand mathematics to write the right command in the Matlab. I have done my duty. This is your turn to solve any question with this one, and please stop recording. Finish.